have with us Professor Mayank Vatsa. He would be speaking on building dependable machine learning and computer vision systems.
Thank you, Anjali. Thank you, Ravi, for the kind invitation. So, a very warm welcome to all of you, and I hope everyone is staying safe. So in this particular talk, I'm going to actually discuss some of the work that we are focusing on building dependable machine learning and computer vision systems. And this work is the joint work with my students and my colleague, Professor Richa Singh. As all the previous speakers have actually mentioned, that machine learning and AI has made a lot of progress. Even when I went to US last year, I saw even people sleeping in the car while their car is autonomously driving, as seen in this particular video, a small video on the right hand side. A lot of computer vision progress has been made. CAPR is accepting almost like 1,300 papers a year. And a lot of buzz is going on, and most of the buzz we can very safely say that it's because of the progress made in deep learning, because of the availability of data, and another primary aspect is because the progress which is made in hardware technology, GPU technology. So if I actually make a statement that given a sufficiently large database, there is a deep learning architecture which would give a state-of-art performance. In today's world, that's not actually invalid. It's a valid statement, and then we would find a deep learning model sitting somewhere where we can make a claim that it's a state-of-art performance. And since I work in a computer vision domain, a very popular case study that majority of the papers, I would say safely 30% of the papers actually in computer vision community, they look at is face recognition, showcasing the progress made in face recognition. In 2020, different benchmark data sets have reported accuracies in the range of 96% to 99.9%. If you see LFW labeled faces in the wild data set, now we claim 99.9% accuracy. In 2014, there was a paper which talked about surpassing human capability of recognizing faces on an LFW data set. And at that point of time, the accuracy claim was 94%. In about 6 years, we are almost hitting, like almost solving the data set. I'm not saying we are solving the problem, we are solving data sets probably. And many other research papers have actually focused on pose, expression, illumination, sketch, aging, and surveillance applications and face recognition. A lot of vendors are selling face recognition products, and a lot of news is also going around face recognition and how they are being used. Right. So, but at the same time, academically, the research is progressing, and we all are trying to ensure that we have a dependable face recognition system available for usage. But as we say, yes, there is a success. A lot of progress is being made. There is always the other side of the coin, and I would like to first showcase the other side of the coin, and then what we are doing, what others are doing with respect to how to mitigate the effect. And the other side is essentially singularities of deep learning. What do we mean by singularities? It's these blind spots in deep learning models which cause some unwanted effects. Right? So let's, in order to actually explain singularities in deep learning model, I would like to take some examples. And being a professor, I always love to pose questions to my audience. So here is a set of questions, and I would request all of you to participate and see if you can answer some of these questions. So again, coming from face recognition community, I will pose questions with respect to face recognition. And another factor is we all perform face recognition day in, day out. So I hope that you don't need any special training to perform face recognition. And that's why I've chosen the tests related to face recognition to articulate the singularity challenges that I'll be talking about. So here is a collage of images in which you need to find out which of them are not of Marilyn Monroe. Okay, so I hope some of you have answered, and now you can match your answer with the answer I'm going to show you. So these images are not of Marlin Monroe. Not sure, Prince, how many of you are correct. Some answers may be correct, some answers may have been missed, but this essentially shows that while we know this famous celebrity, but it's hard to ensure that we all are consistent in terms of recognizing the person correctly. Another example, and this is a collage of images. Some of them may or may not be belonging to Heidi Klum. Heidi Klum is a supermodel and a very famous supermodel. And you need to find out that which of these images belong to Heidi Klum, which of these images do not belong to Heidi Klum. I'll pause for a couple of seconds and you can type your answers. Okay, so I'll go to the answer, and I hope some of you are correct in that. If not, then we have one more question to go. So actually, all of them belong to Heidi Klum. So Heidi Klum is very famous not only as a supermodel, but she's also very famous with respect to using accessories, disguise accessories, or makeup accessories to for Halloween costumes. So during Halloween, she changes her getup and then face recognition systems have hard time in recognizing her when she undergoes these kinds of variations. Probably the final question. These are images of n number of babies. There are 12 images total, and there are n number of babies in this collage. Now the question is that how many unique babies are there? Some images may belong to some of the multiple images may belong to one baby, and some of the images may belong to like a single image only for other babies. So you need to find out that value n, that how many babies, unique babies are there in this particular image. Okay, so I'll now move on to the answer slide. So there are total 11 babies, and then if you see the bottom left-hand side, 2 babies, their hairstyle, though babies don't have much hairstyle, but if you look at the 3-4 strands of hairs, probably looking at them, one can say, yes, these 2 images belong to the same baby, but other images belong to different babies. In fact, there is a pair of twin also in this particular collage. But while many of us are not good at recognizing babies, this is a valid study, and primarily because we are not trained for recognizing babies. If I show these images to nurses in neonatal care unit, probably they will have a better answer compared to the normal people like us, because they see different babies in and out, even many times multiple babies in neonatal care unit. And therefore, they have that kind of training over a period of time. They build that capability to perform newborn face recognition. So in our research on newborn face recognition, we showed that face recognition systems have hard time in performing this kind of recognition performance. And later I'll also show some of the results in my slides. So this essentially, these examples show that the singularities of deep learning systems can cause multiple unwarranted effects. And the singularities can be understood based on this particular image that is shown over here on the right-hand side. Suppose we have trained a classifier for 3 classes, and we have trained very nicely the decision boundaries of 3 classes. The gaps between these classifiers or these decision boundaries can be singular points where an attacker can attack those points and cause unwarranted effects. Or naturally, the samples may come in a way that they were not seen by the classifier in past, or the limited samples may have caused missing those points altogether, and therefore there may be an effect of bias. Even the data bias can also actually come in, where limited sample or of biased sampling can also actually cause those singular points. And in this particular talk, I'm going to focus on the remaining slides, I'll be focusing on these two singular points, bias and adversarial attacks. Most of my applications are going to be around face recognition, and some of the work that I'm talking about has been published in AAAI 2020 this particular year. So as I said, the first bias that we'll talk about is, first singularity that we'll talk about is bias. So if Partha has talked about NLP, and I'll take the example from NLP, very famous example, that if father stands for doctor, then what would stand for mother? And the popular exam answers that we get from some of the NLP systems is nurse. Similarly, if we say a man stands for computer programmer, then a woman stands for what? And again, popular answers have been homemaker. So word embeddings have shown biasness, and this biasness comes from the data that is being used to train this particular model. And historically, even in our minds, generally we see most nurses as female and most doctors as male, right? So in fact, within medical profession, we see many female doctors as gynecologists, and if we see any male gynecologist, we are surprised, right? So that's a bias in the system, the society, and probably the data itself, which is probably biased. And then to further articulate, I hope Manish also sees this at some point of time. Go to google.co.in and do the image search as wedding. So try this yourself, and then you'll see what I'm talking about. I hope you went to google.co.in and click on the image search and search the word wedding. I hope you are able to see. So this is the one that I got before the presentation. I just wanted to ensure that what I see, you also see the same.
Yes.
So is there anything peculiar about this image? Something which is not right? See, I asked you to search on google.co.in, and that's what, like, even my, if you see the image search tab, it says google.co.in, right? And I'm searching wedding. I'm sitting in India. I'm not finding, probably just one example among all where it says, one can say that it's Indian wedding. The rest of the wedding images are not belonging to Indian settings. Okay, so I hope you're getting where I'm heading with respect to bias. And it seems that Google search engines are biased. So another interesting example is now search, replace the word wedding to CEO. See what you get. Do you get this collage of images?
Yes.
And you see Google CEO or Alphabet CEO somewhere at the 12th result, not as the first result. And probably just one Indian in this whole collage. Whereas we always see these WhatsApp messages or Facebook messages or LinkedIn messages that how many Indian CEO we have in top companies these days. Right, but when we search these tags, probably we get some of the results which probably may not be totally incorrect, but maybe a little biased on some side. In fact, last year when I was searching the same like keyword CEO, I couldn't see any female faces, but now we see some female faces. Still a lot of white faces I see, and in other mixed races and other skin color tones are not still popular. And as I said, like even Sundar Pichai's photo is also at the 12th photograph. And those who like cricket, we all know 12th man concept. But not to say means he should be the first man, he should be the opener there. So this essentially shows that even our systems, a popular machine learning system, Google's image search itself is biased in some ways. And probably that bias is coming from data, or the bias is coming from the society itself. And there was a paper in Nature in 2018 which actually showed that if you search bright in Google, probably you would see more white faces with the Western wedding, the Christian wedding kind of examples rather than Indian wedding. However, I see even this morning when I checked this, this has been corrected to a very large level. Probably the paper was published in Nature, and that's why Google may have corrected, but other examples also require some attention from researchers around the world. So we have been working on this particular problem statement with respect to face recognition. There has been a lot of news about face recognition being biased, a particular race, and particular skin type, even particular gender. In Indian setting, we tried these two. We have been also trying that what is happening with respect to face recognition in India. And these are two examples showcasing the challenges. If you see the first example in which one of my colleague from IIIT Delhi, I took his photograph and tried to match against 10 people from similar appearance. In this example, with beard, mustache, and this wig, or not wig, the pagadi. And then he was not matched as the first match by multiple face recognition systems or open source models, where the claim was that these models perform more than 99% accurately on LFW dataset. And in this particular example, if you see the first example, first score was 0.8, a very high confidence score, whereas his own match is a second best match with a very large gap of more than 0.13 score gap. The second example is when I gave when my students gave input as Mary Kom image, and then tried to match against 10 women from Northeast. She didn't show up in top 3. So this essentially shows that the face recognition models have biased behavior based on particular race, ethnicity, appearance. So these kinds of examples are already shown. And what we understand is that in these examples, whether it's popular examples that are there on web or our experiments, they all have shown that if the training database is has limited samples of pertaining to a particular class, then we see biased behavior. So we can safely say, and we can safely articulate that many AI systems have biased behavior because of being trained on biased data. And the recent instances have actually shown that a biased AI system can erode trust between humans and machine, which something as a machine learning researcher, as a computer vision researcher, I would not like to. So our research has also been trying to first understand how face recognition is getting impacted with respect to different race and age specific features, and then how we can mitigate them. We have shown that last year we showed that if you train on one ethnicity and test on another ethnicity images, the performance drops significantly. If we train on one particular age group, the best performance actually we achieve is the age group of 15 to 32 or 15 to 35 years age. And if we test on lower age group of 0 to 14 years, different face recognition systems, the open source face recognition systems perform very poorly. And this essentially shows that face recognition, if we have to ensure that these vision systems, these face recognition systems are applicable throughout, then we still have to perform a good job in terms of training them with unbiased data. We are also trying to actually work on different, look at different pipeline steps of a face recognition system or object recognition system at large, that what we can do to mitigate the effect at a pre-processing level, at a post-processing level, or at a feature extraction level. And one of our recent work actually talked about, can we identify those filters or features which are focusing on the biased effect, and can we drop them so that the effect of the bias is reduced. And then we showed that this kind of filter drop of like biased filter drops help in improving the performance of systems. Now, quickly, I'll go to the second singularity that I want to focus on is adversarial attacks. I'm sure you all have seen this video.
Here we go. President Barack Obama.
In which
when you
overlays
giving a speech,
and one can
make
put
sure
anything in
you
anyone's
a lot of pauses.
Here, the actor actually said something which was overlaid on Barack Obama's video, and it was shown as if Barack Obama was making those statements. Even there are videos in which Obama was selling Nike shoes. And this whole era of deep fakes have created a lot of issues. Even recently, Manoj Tiwari's deep fake videos also circulated during election times. In fact, we have seen some videos like this where it was claimed that Terminator is coming soon, in which robots can start hitting people, men and women, and then, which actually is not right. Means we can't trust everything because this is all computer generated videos in which this was a staged video essentially, and one cannot differentiate whether it's a real or it's actually a fake video. We have seen a lot of examples when the moment, let's say, Apple has launched a face recognition, Face ID system, and it was broken within few hours of launch. We have a lot of research going on where we can how we can fool face recognition systems using different kinds of attacks. In fact, our Mission Impossible series has shown that we can use silicon masks to fool the face recognition system. And it's just not the movies. While this is a nice example of showcasing, and if you see, this is how in almost every Mission Impossible movie,
Such a nice car.
the actors have actually used silicon masks. And while these are in movies, we also have real life examples in which robbers have used the silicon mask to fool law enforcement officials. Different morphing attacks have been used, different Photoshop attacks have been used to fool on and to make digital attacks. In CVPR 2017 and CCS 2016, it has been shown that even imperceptible or perceptible noise can be added, and that kind of noise can fool different kinds of face recognition systems, including Google's, Oxford's, and Facebook's. Now, GANs can generate non-existing celebrities, non-existing identities. All three examples over here do not exist. These are generated via generative adversarial networks. And just imagine if we could use these images to create their Aadhaar cards. Thankfully, Aadhaar requires multiple modalities, but one can, and then there is a human in the loop, but who knows, in future, this kind of attack may happen. So broadly, to understand how perturbation adversarial attacks work, it's essentially trying to perturb the input data in some ways, whether physically or whether digitally. So given input data X, if we perturb by adding some noise, if this noise can be physical and digital, how can we fool the classifier which has been trained on unperturbed data? So that's what adversaries would try to do, to try to find out those points where we can shift the entire data in a space where you start seeing a lot of misclassifications. And this kind of noise, if you see, if you add this noise in the input image, you can change your class labels. Like flagpole can be classified as Labrador, for example. And this happens because either we are doing local generalization or we are doing extreme generalization, and those local generalization can cause singular points, and which can cause the challenges with respect to adversarial attacks. An attacker can try to find out those singular points where it's easy to misclassify the samples. There are a lot of research. While some research has gone into how to attack the systems, a lot of research is also going on how to mitigate these adversarial perturbations, these adversarial attacks. So people, including us, we have looked at can we detect the attacks? If we detect the attacks, can we mitigate them? And if we are able to mitigate, then can we perform classification and matching tasks after mitigation? If not, then we can be thrown out. And we have been building different architectures where how we can build defendable networks. We are changing, we are making changes at the architecture level. We are trying to use some problem-specific solutions to build a secure and defendable network. We are also looking at this blockchain technology where we can protect the integrity of deep learning architectures using blockchain concept. And then we have in our recent papers, we have shown that the blockchain can be actually used to protect the AI systems at the model level, where we can secure the weights and we can secure the way actually the network is triggered using blockchain technology. More details can be found in our papers, in 2019 papers and betas and CVPR workshops. So to summarize, we have to look at how actually we can build dependable AI systems. And when we say dependability, I have focused on two components, on safety and bias-free. But there are other components such as explainability, interpretability, and trustworthiness, which also requires a lot of attention. And in the interest of time, I'm not touching those topics. However, there is an entire course on dependable AI at IIT Jodhpur, which my colleague teaches over here, and which is also a core course in the BTech in AI and Data Science program, which we are launching from this year. The key takeout of my talk is that we should build algorithms which are agnostic to database models and attacks. And we should not solve databases, we should solve essentially problems. And that would give the true sense of where the community is growing. We should ensure that we can compute the robustness level of an algorithm. It's how robust the algorithm is against bias or attacks or trustworthiness. We should develop defense mechanisms so that the trust on these AI systems are maintained, and we should also, as research community, should also continuously look for newer data sets and newer benchmarking protocols to identify the singular points. Rather, we should identify them rather than compared to an attacker. So if we can identify them, if we can fix those singular points, that would help the growth of AI community. And finally, it's going to be a cat and mouse game. And so we have to continuously evolve. The AI systems have to continuously evolve and ensure that the systems are dependable. You can reach me at my email ID, and for my research papers, you can visit my lab's website. Thank you very much.
Thank you, Professor Vatsa, for that very, very enriching talk today, because it was firstly very interactive. I think the audience was quite engaged in your talk. We could witness that. And plus, we could also notice that these are some areas which are quite popular these days, how we can just differentiate between what is fake and what is real when it comes to screening, when it comes to online mechanisms, and how do we eventually ensure that there is a pure transparency. So now we can take up some questions along these lines. There is one question also, related to this only. How do we detect whether the data set is biased?
So there are some techniques where which gives a score that if your model is biased or if your data set is biased. So I'll take an example of face recognition. If you again intuitively, if your database does not have any female representation, but you're training your model or the system on that particular data set, and then if you apply it on testing and if you start seeing female faces, most likely your system will perform badly. So there are actually, depending on different applications, there are techniques to give a score which is called as a bias score. And even NLP domain has now some matrices which can actually say that this model is biased by this particular percent, or this database is biased by this particular percent. So I can share some of those research papers, or if you just do a Google search, mostly those results will not be biased.
Absolutely, yes, that would be interesting. There are two questions related to face recognitions. One is highlight the reliability of, there's a person who's asked, highlight the reliability of retinal scans in face recognition. And there is another question related to, so it's a longish question, given that faces are not indicative of criminal traits, why people still deploy face recognition systems to detect criminal traits. These systems, so this is another comment that has come from the same person, Venkatesh. These systems were found to be inherently flawed and biased, where they have classified throwing faces or underrepresentative communities. Kindly convey your thoughts on deployment of such systems and how to combat such biased applications.
Okay, that's a very good question. So I'll answer the first question first about the usage of
Retinal scans, yes.
retinal scans. So that's retinal scans are a different modality. I would shift the question a bit to iris recognition. So there is a difference between retina scan and iris recognition. So iris recognition is more popular. Even in Aadhaar, we use iris recognition, and they are more secure compared to face recognition. But we have also, in fact, our research group has shown that there are challenges with respect to iris recognition as well. See, so if there is a pattern, then one can design mechanisms to fool that particular model associated to a pattern. If someone undergoes cataract surgery, we have shown very recently, like last year, in one of the Nature Scientific Report papers, that cataract surgery and cataract itself can actually cause some unwarranted results. One can wear colored contact lenses, and that can cause challenges. And those are the ways, like in place of wearing a face mask, you can wear a colored contact lens, and that can cause challenges. So every modality you would find that there are pluses and minuses. Face probably is more intuitive for us to understand. To answer the second question, Venkatesh, when I subscribe not to use face recognition for criminal activity, or recognizing if someone is criminal or not, because again, it's a biased data, right? Yes. So, about a couple of years ago, there was a research which said that using your face, I can tell you what is your sexual orientation, whether you are straight or gay. So these kinds of research I do not subscribe to, and I believe many in the research community also do not subscribe to. My message is that we should not use any data which is not intended for that particular task. If I'm giving my face to, if I'm uploading my face on Facebook or LinkedIn, that is for sharing some images to the community, not to use it for recognizing my, using to train a model for doing X task. So again, privacy preserving aspect of faces or models is exceptionally important and should not be used for the task for which I have not given the data for. Right. So that is something which we should all look for. And I believe Facebook has changed some of those terms and conditions.
Yes, but face recognition is also very common when it comes to mobile phones. I mean, like Apple and all, they have this feature, so which is like, again, quite biased. Thank you, Professor Mayank Vatsa. Thank you so much for your time. It was really